Today I'm going to show you how to write a schedule, and I'm working on this project. And this project has a lot of layers of strips of glass of different colors and also a lot of frit kind of sandwiched in between all of those layers of glass. And my objective with this schedule is to try to get all the bubbles out of this piece. I've done this project a few times before, and I always end up with a lot of bubbles trapped in the glass and also bubbles that have come to the surface of the glass. And that creates a lot of problems, as you know, because you don't want bubbles on the surface of your glass, because then they pop and they have pits and it's not a pretty thing. So I'm trying to get all of the air that's trapped between all of those layers of glass and in the frit to come up to the surface during the bubble squeeze, and then I'll take it to the full fuse. I'm going to take the glass up pretty slowly at 200 degrees an hour to 300 degrees, and I'm going to hold it for 10 minutes just to kind of get everything warmed up. Then I'm going to go a little bit faster to 1,000 degrees, hold for 20 minutes. Holding at 1,000 degrees for at least 10 minutes will get your glass ready for the next segment. And then starting with segment 3, this is going to be the very long bubble squeeze. So I'm going to go very slowly. So I'm going to go 50 degrees an hour up to 1100 and hold for 30 minutes. That's my first segment of this bubble squeeze. Then I'm going to go 50 degrees an hour to 1150, hold for 30 minutes. 50 degrees an hour to 1200, hold for 30 minutes. Then I'm going to go even slower. 50 degrees an hour up to 1225, hold for 30 minutes. And then 50 degrees an hour to 1250 and hold for an hour. So that segment right there of the firing schedule, these 5 steps, is my bubble squeeze, which is a really long bubble squeeze. Now I'm going to go and add another segment because I want to go up to my full fuse temperature. Now I can go fast because hopefully all those bubbles are gone. I'm going to go to 1450. And I'm going to hold there for 20 minutes. I'm going to add another segment. And now I want to go down to my annealing temperature as quickly as I can so that I don't get any devitrification in my project. The range between about 1250 and 1400 is where you get your devitrification. And going up to your full fuse is not as bad as cooling. So you want to cool as quickly as you can. I'm going to cool down to my annealing temperature, which for System 96 glass is 950. And this is a thick project, so I'm going to want to anneal for quite a while. We're going to anneal for 4 hours. So bubble squeeze, full fuse, anneal. And now I'm going to add even more segments because since this is a thick piece, I'm going to want to cool down very slowly. So I'm going to go 45 degrees per hour down to 700. And we're going to hold there for 20 minutes. And then I can go a little bit faster after that. If this was thicker, I'd probably keep that 45 degree per hour ramp speed, but it's not going to be as thick as some of my other projects. So I'll go 100 down to 200 degrees. And I don't need to hold there. And once it gets down to 200 degrees, I'll just let the kiln cool naturally after that, and we should be fine. We're going to heat the glass up fairly slowly to 300 degrees, hold it for 10 minutes just to kind of get everything warm. Then I'm going to go a little bit faster up to 1,000 degrees, hold for 20 minutes again to get everything equalized. Then I'm going to start this very long bubble squeeze segment. Then I'm going to go up to my full fuse, hold for 20 minutes because it's a thicker piece. Cool very fastly to my annealing temperature, hold for 4 hours because it's a big, thick piece. And then cool very slowly down to 700, hold for 20 minutes, and then cool at 100 degrees an hour down to 200 with no hold.